You know, we all think of math as this thing we had to learn in school, but what if it's something else entirely? What if it's more like a language, a powerful, kind of hidden language that describes, well, everything, from the choices we make every day all the way up to the fabric of the universe itself? Today, we're going to dive into that.
So what if math really is a secret code? A set of keys that can unlock totally new ways of looking at pretty much anything. That's what we're going to do. We're going to decode 3 different levels of this language. We'll start with something simple, a line, then we'll move to a curve that can make you money, and we'll finish with the actual laws that govern light itself. Pretty cool, right?
All right, let's start with something we all know, or, something we've all seen before. A simple line, an equation you've probably solved 100 times. But here's the thing. The real lesson isn't about getting the right answer. It's all about the process. Because with a line, precision is everything. You make one wrong move, and the whole thing just falls apart.
Okay, check this out. This shows you just how easy it is for one tiny mistake to throw everything off. So on the left, you see a really common error that gets you x equals 10. But that's just wrong. It leads to this impossible statement that 4 equals 19. No way! Now look at the right. The correct process gets us to x equals 40. And that one, it works perfectly. So what's the only difference between a total mess and the right answer? It's just the order of the steps. And here's the real key. To solve this, you actually have to work backwards. You have to reverse the order of operations. So first, you get rid of that subtraction by adding 1 to both sides. Boom! You get 1/2 x equals 20. Then you undo the multiplication by multiplying both sides by 2. And just like that, you land on the right answer, x equals 40. It's such a powerful lesson in precision, and it's all hidden right there in a simple line.
Okay, so a line demands precision. Got it. But what happens when we level up from a straight line to a curve? Well, for that, let's leave the classroom behind and head out to a farm. We're going to see how the predictive power of a parabola can literally optimize a harvest and turn a pretty good year into a great one.
So, imagine you're a farmer. You're trying to figure out the absolute perfect number of seeds to plant. If you plant too few, you're just wasting valuable land. But if you plant too many, the plants all start competing with each other for water and sunlight, and your harvest actually gets smaller. So this farmer went out and collected some data. And you can see it right here. The yield goes up and up for a while, but then it starts to drop off. This kind of pattern is just screaming for a mathematical model.
And here, you can see that pattern illustrated perfectly. When we plot out those data points, they form this beautiful, clear curve. That's a parabola. And the amazing part is, we can describe this whole relationship with just a single quadratic equation. And that equation, it holds the secret to the perfect harvest. It's hiding right there at the very peak, the top of that curve. So the big question is, where exactly is that peak?
Well, the math gives us an incredibly precise answer. By calculating the vertex, that's the peak of the parabola, we find the exact optimal planting density. It's not just 20, and it's not 21. It's a very specific 20.81 plants per square meter. That is the absolute sweet spot, where the plants have just enough room to thrive without an inch of wasted space.
So, what do you get for all that mathematical precision? What's the payoff? At that perfect density, the model tells us we can expect the maximum possible yield, 734.49 kilograms per hectare. I mean, think about that. Just by going from a few data points to a simple quadratic model, this farmer can optimize their entire operation. That's the power of the parabola.
Okay, so we've seen how math demands precision with a simple line, and how it helps us optimize things with a curve. Now let's zoom out. I mean, way out. We're going from a single farm to the fundamental forces of the entire universe. Because out here, we find equations that don't just model a specific situation, they describe reality itself.
Let's talk about what is, without a doubt, one of the crowning achievements in all of physics, Maxwell's equations. Now, this isn't just one equation, it's a set of 4. And together, they perfectly describe this incredible dance between electricity and magnetism. Seriously, these equations are the bedrock of, well, almost all of our modern technology. We're talking electric power, radio, Wi-Fi, all of it.
So how do these 4 laws work together to create this magic? Well, the first 2 kind of set the stage. One says electric fields start from charges. The other says magnetic fields always form these complete loops. Simple enough. But it's the next 2 that reveal this deep, incredible connection. A changing magnetic field creates an electric field, and a changing electric field creates a magnetic one. You see, it's this beautiful, self-perpetuating dance.
And this is what led to the ultimate aha moment. When the physicist James Clerk Maxwell put all these ideas together, he realized this cycle of electric and magnetic fields creating each other would produce a wave that travels through empty space. So he calculated the speed of that wave, and it perfectly exactly matched the known speed of light. In that single moment, everything changed. The math had just proven that light itself is an electromagnetic wave. It unified electricity, magnetism, and optics forever.
So, where has this journey taken us? We've gone from a simple line all the way to the cosmos. We've seen how this language of math can demand precision, how it can unlock optimization, and even describe the fundamental rules of, well, everything. It's really just a powerful new lens for looking at the world.
Think about it. We started with the humble line. That taught us that the process, being precise and repeatable, is everything. Then, we moved up to the parabola. That showed us how to take real-world data and turn it into a tool for optimization, for finding that perfect sweet spot. And finally, we zoomed all the way out to Maxwell's equations, which gave us a description of reality so profound it revealed what light actually is, from a line to a harvest to the universe.
You see, each level we looked at revealed a deeper and deeper layer of understanding. It really shows that math isn't just about crunching numbers in a classroom. It's a way of thinking. It's a framework for solving problems. And yeah, it's a code for describing the world all around us. Which kind of leaves us with one final thought, one last question for you. What patterns in your life or your work or in the things you're passionate about are just sitting there, waiting for the right mathematical key to unlock them? What part of your world is waiting to be decoded?